Welcome to the captivating world of computer hardware manufacturing. From smartphones to supercomputers, every device relies on a diverse array of chemical and physical materials. How do these raw elements transform into cutting-edge technology? How do they work together to make our devices faster, smarter, and more efficient? Join us on a journey from chips to screens, uncovering the scientific secrets behind your favorite gadgets. Let's dive into the materials that power our digital age. At the core of every computer is the chip, and silicon is its star material. Abundant in the Earth's crust, its unique crystal structure makes it the perfect semiconductor. By doping it with tiny amounts of boron or phosphorus, we create p-type or n-type materials, controlling electric currents to form transistors, the tiny switches that power our chips. Photoresists, which are sensitive to light, enable nanoscale circuit patterns to be etched onto silicon wafers. Meanwhile, silicon dioxide acts as an insulating layer, preventing current leakage and ensuring the circuit's reliability. These are the materials that drive the miniaturization and speed of our chips, fueling everything from smartphones to artificial intelligence. Inside a microchip, much like a bustling city of countless electronic pathways, electrical currents must flow precisely for the chip to function correctly. To control these currents and prevent signal chaos, a crucial component is added, a highly insulating layer of silicon dioxide. This layer acts like a perfect traffic control system, ensuring every electrical signal stays in its own lane. This flawless control is the key to unlocking the chip's true power and potential. Once unlocked, the chip operates at an incredible pace. If you could zoom in, you'd see millions of tiny transistors flickering in perfect synchronicity, processing information at astonishing speeds. It's this vital insulating layer that makes modern high-speed computing possible. Powerful chips need connections to function, and metals are the key. Copper, with its low resistance and high conductivity, forms the intricate wiring inside chips and on circuit boards, ensuring rapid signal transmission. Gold, highly resistant to corrosion, coats connectors for dependable, long-lasting contacts. Circuit boards use epoxy resin substrates, like FR4, which are strong, lightweight, and insulating. Solder, often a tin-silver alloy, bonds chips to boards, creating robust electrical and mechanical connections. These materials enable your device to light up, supporting everything from a mouse click to seamless video streaming. Now, let's tackle how we keep chips cool. High-performance chips generate significant heat, making cooling essential. Ceramics, such as aluminum oxide, are used in chip packaging due to their excellent thermal conductivity and electrical insulation, efficiently dissipating heat. Thermal interface materials, like silicone grease or graphite pads, transfer heat from chips to heat sinks, maintaining safe operating temperatures. Adhesives and sealants shield hardware from moisture, dust, and physical damage, enhancing durability. These materials ensure chips remain stable during demanding tasks, like gaming or video editing, while extending device lifespan. Let's move on to the materials behind displays and storage. Displays and storage bring hardware to life. Glass serves as the smooth, transparent substrate for screens, offering durability and high-temperature resistance for vibrant visuals. Rare earth elements, like indium and gallium, form transparent conductive films, such as indium tin oxide, enabling responsive touchscreens. Magnetic materials, including iron and neodymium, power hard drives by storing data in tiny magnetic fields, preserving your photos and videos for years. These materials create dazzling displays and reliable storage, enriching our digital experiences. Finally, let's wrap up and look to the future. From silicon to rare earths, these materials shape the hardware that powers our world, making devices faster, lighter, and more reliable. They form the foundation of technological progress. Looking ahead, emerging materials like two-dimensional materials or quantum chips promise to unlock new possibilities, driving the next wave of innovation. Thank you for joining us on this exploration of computing's material marvels. Stay curious and keep discovering.